Last class we talked about independent groups design. So one kind of experimental design. Today we're going to move on to talking about repeated measures, which is the second type of experimental design. If you'll remember, the key to independent groups design is that we had different people or different participants at each level of our independent variable. Repeated measures takes a different approach to manipulating an independent variable. With repeated measures design, we have the same people conducting or participating in each level of the independent variable. So they complete, each individual person does each level of the independent variable and completes the dependent variable measure at each condition. So for example, maybe I'm interested in whether providing students with an open notebook, open note test causes more test anxiety or less test anxiety. If I wanted to take an independent groups approach, I would give one class an open book test and one class a closed book test and have each class assess their anxiety. But I might do the same experiment using a repeated measures design, and instead of having different people in each group, I might use the same group. So I might take one class and have them take the first test open book and rate their anxiety, which would be my dependent variable, and then have them take the second test closed book and have them rate their anxiety. So again, they're doing the dependent variable multiple times and they're participating in each level of the independent variable. The repeated measures are when each participant does each level of the independent variable. But there are two different kinds of repeated measures. In an incomplete design, each participant does each level only once. So incomplete is when each person does each level only once. And there are a couple of strategies that we can use in terms of determining which order the conditions are going to go in. We'll talk about those next. A complete repeated measures design is when each participant does each level of the independent variable multiple times. The reason we call it a complete design is because we're able to balance practice effects, which we'll talk about next, more thoroughly in a complete design. So a complete repeated measures design is really the ideal, and with a complete repeated measures design, each participant does each level of the independent variable multiple times. And the two strategies that we have for determining order for those are block randomization and ABBA counterbalancing. The practice effects are when participants' response patterns change because they're being tested repeatedly. In a complete repeated measures design, each participant is doing each level of the independent variable multiple times. So it can change in one of two ways. So practice effects may happen in that people get better with repeated testing. Maybe if you're measuring something like reaction times, they get quicker with time as they get used to the task. Or they could also get worse. So if you're having them fill out the same questionnaire over and over again, they may get bored, so they stop focusing and they get less good at the task. Either way, what these practice effects can result in is people give different answers at the beginning than at the end. If we have some participants do condition A first, if everyone does condition A first and everyone does condition B second, we never know whether they're really better at condition B because of some way we manipulated the independent variable, or whether they're better at condition B because they had practice after doing condition A. So there's two methods for figuring out what order we're going to get the conditions in complete repeated measures designs. Those are block randomization and ABBA counterbalancing. So again, with these designs, what we're worrying about is what order are participants going to see the conditions in. So just to reiterate some vocabulary that we talked about, so remember that conditions have to do with the different levels of the independent variable. Let's say I'm interested in people's different responses to pictures of human face, animal faces, and inanimate objects. Each one of those is going to be a condition. A trial is a measure of a reaction to each individual image. So one response to a picture, whether it's a human face, a response to an animal face, or a response to an object, that single response is going to be a trial. A block is a group of trials that contains each condition of the independent variable. So a block will differ depending on how many conditions you have, but if you have 4 conditions, a block is going to have one of each condition. So with block randomization, what we're doing is we're generating a random order of trials within a block. So we're going to say we're going to have a block, which means we're going to have one of each condition, but the order that those conditions are going to come in will be random. With a complete repeated design, again, each person is doing each condition more than once, which means you're going to have at least 2 blocks, which is the complete repeated measure design. In block randomization, you have a new random order for each block. So in terms of picking what the random order is, we have a specific strategy. If we just picked random numbers off the top of our head, it likely wouldn't be random. So we're going to use the Appendix 1, which is on page 443 of your textbook. I've got a picture of part of it right here to help us determine that. The way we're going to determine the order of the conditions within each block is we're going to assign each condition a number. So let's say we're doing human faces, animal faces, and objects. We'll say human faces is 1, animal faces is 2, objects is 3. Once we've assigned our conditions to a number, we're going to go to page 443 and look at our table of random numbers. Now again, the point is that this is random. So you can start at any row. I think it's easiest to go across the rows, but you can also go down the column. But start at any row, and you're going to look for which of your numbers indicating a condition appears first. Remember that we're doing this by block, so we only want one instance of each condition. So if your number appears multiple times, you would ignore all of the first instance. Also, there's a lot of extra numbers in here that we don't need, so we're just going to focus on the numbers that we've assigned to our block. So in this case, 1, 2, and 3. Let's say we start at row 6. We're going to go across. Our first number is 7, 7, 9. None of those are assigned to conditions. We ignore them. 2. We've determined that one of our conditions is number 2, so that condition is going to go first. The next number we come across is number 1, which means that condition 1 is going to go second. And then, since we only have 3 conditions, either we can keep going until we come across a 3, which doesn't happen until column 6, or we know that there's only 3 conditions. If we're doing this by block, the third condition must be the third one. So the random order of conditions for this block would be condition 2, and then condition 1, and condition 3. And I'll go back and look at the conditions I assigned to those and say which tell them in terms of the condition. So animal faces first, then human faces, and then objects. That is how you get your random order by block. And again, each block has a different random order. So if you need to design 4 blocks, you're going to need to do this 4 separate times to get 4 different random orders. Another strategy that can be used when you have a complete design is called ABBA counterbalancing. ABBA is very convenient because you can balance the practice effects with just 2 trials in each condition. For block randomization, you need many, many trials of each condition. What you do with ABBA essentially is you start with a random sequence of your conditions. So you do the same thing as you would in block randomization. You get a random block order. So that's the first order, and then you just flip it and reverse it. So if your first random order is condition A and then condition B, the second block is going to be condition B and then condition A. Now it's really important to note that you can only use ABBA when practice effects are linear. So what linear practice effects mean is that participants change the same way with each presentation of a condition. So they get slowly better and better with each trial they do. Sometimes, though, we see non-linear practice effects. You can think of these as kind of that aha moment after the first trial. They struggle the first time, the second time they just get it, they pick it up, and they get much, much better. If we have these non-linear practice effects, we really need to do block randomization instead. This just demonstrates the 2 different types of practice effects with the example from your textbook. If we have linear practice effects, we can see that on trial 1, they don't get any better, but on trial 2, they get 1 point better. Trial 3, they get another point better. So again, you can see they improve 1 trial per practice. or 1 point per practice per trial. With practice effects that are nonlinear, there's that aha moment, and once they figure it out, they're much better. So the first trial, they don't get it. The second trial, they get it. They're 6 times better, and boom, they're consistently 6 times better. So remember, with a complete design, each participant is doing each condition many, many times. This way we can balance practice effects within each person. If you get successively better with each trial, if you do bad on the first 2, you'll see those conditions again later on. With incomplete design, each participant experiences each condition only once. So we have a new issue that we need to deal with. So we have to balance, instead of balancing within person, we have to balance across people. So there's a couple of strategies. The first is all possible orders. With all possible order, we're basically doing every possible order of our condition. So again, we're doing it by block, and we need to have at least one person randomly assigned to each order. If you have 2 conditions, this is really easy. So your 2 conditions are A and B. There's 2 possible orders. One person does A and then B. The second person does B and then A. This is pretty easy. However, this gets much more difficult the more conditions you have. If you have 3 conditions, there's 6 possible orders, which means you need at least 6 participants. If you have 4 conditions, there's 24 possible orders. So some people see A and then B and then C and then D. Other people see A and then B and then D and then C. And again, we want every possible combination of these orders. So if you have a lot of conditions, this gets out of hand pretty quickly. There's a couple other strategies. So if we have an incomplete design, meaning each participant does each condition only once, and we don't have enough to do all possible orders, we can do a select order. There's a couple of different ways we can do this. One of the best one is a Latin square. So with a Latin square, there's a couple of criteria, but let me just tell you the way you read this table is the rows are the order that each participant sees them. So the first participant in the first row would see A first, B second, D third, and then C fourth. So that's the way you read it. So this is giving you the orders of 4 participants, or 4 groups of participants. And again, this is an experiment with 4 conditions. So there's a couple of criteria for a Latin square. The first is that each condition appears in each ordinal position once to balance practice effects. A happens first once, A happens second, in that last row, third in the second row, fourth in the third row. So you can see A happens in each ordinal position, which means that some people get A first, but some people also get A last. That helps us balance some of the practice. The second condition of a Latin square is that each condition precedes and follows every other condition once. So we have A and then B, but then we also have B and then A. In orange, we've got B and then D, but we also have D and then C. This also helps us control for order effects, because maybe one condition has a particular effect on a second condition. So maybe C improves D if it happens before it. Well, we don't want every time we see D to have that precede practice. Now, Latin squares are kind of complicated to make, and basically what you need to know about them is you need to understand kind of how what the criteria are for it to be classified as a Latin square. You won't actually need to make one. What you need to do is be able to take this, see this, and implement it in the experiment. So if I say you're doing an experiment with 4 different conditions, here's what the conditions are, give me a Latin square. You don't have to make a Latin square. You have to say, okay, my first condition we're going to call A. I'm going to put the name of my first condition in place of A, and that's the way you need to use it. A final option for an incomplete design is random starting order. So here again, we're going to start with a random order of conditions, a random block. And rather than rearrange them in that fancy way that they did for a Latin square, another thing we can do is just shift them. So in this one, in the first row, the first person who does the experiment sees A, B, C, D. The second person who does the experiment, A, gets shifted to last, and they see B, C, D, X. So here we have each condition appears in each ordinal position. We've got A first, we've also got A fourth. But we're not balancing for order of conditions. You can see almost every time someone